everyone. Welcome to another episode of AADYA GEO TALKS. Here we bring the brightest minds in the field of Earth and planetary science. We talk about their different journeys in the field, how they have pursued this particular field, and we decode some really cool topics related to Earth and planetary science. And I'm your host, Bharti Sharma, geologist and founder of AADYA Planetary and Geoscience Research. I started AADYA back in 2023 when I felt that there is a need for collaborative research environment, particularly in India, related to traditional sciences like physics, geology, and chemistry. So when I was working, or you can say when I was volunteering with these engineering projects related to space robotics and space engineering, I realized, okay, these guys are very cool. They jump into science projects any time during their bachelor's or master's. They don't feel like, okay, it has to be a summer internship or their dissertation project. And on the other hand, there's a huge lag for independent scientist kind of environment in India, particularly. So I felt, okay, this has to be at the forefront of AADYA. And next, I am a field geologist and my forte is field geology. So I kept these two elements at the forefront of AADYA, where I teach students field geology and bring some really cool collaborative research projects in the field. And for AADYA GEO Talks, I started this last year only during the World Space Week, when I was organizing various activities related to World Space Week with different organizations. And I felt, okay, there is nothing special for my own field, that is Earth and planetary science. So I thought, okay, why not start something of my own then? So that's how AADYA GEO Talks was born. And I interviewed like 3 scientists at that time, which was my mentors earlier in the field of geology only. And she, Dr. Binita Fatiyal ma'am from BSIP, she's the one who taught me how you can, combine these two different fields like geology and planetary geology, because she herself started this field that she's a paleoclimatologist, and then she got into planetary geology as well. She's the best person when it comes to Ladakh's geology and geomorphology, and she transitioned into the field of planetary geology. So that's how AADYA Planetary and Geoscience and AADYA GEO Talks for you. And for today's episode, I'm so excited because I have, someone from my own field, like planetary geology and geology. So she's a true powerhouse when it comes to the field of space and exploration sciences. Joining us is Namishka Mendonca. She's a geology graduate from St. Xaviers Mumbai, and then she continued her studies at Curtin University, Australia. She's also a STEM educator at iFly Indoor Skydiving. How cool is that? Really want to know about iFly Indoor Skydiving and your role in that. And apart from this, you have worn many hats when it comes to Space Nerd or science communication. You have been the social media manager at Asia Pacific Oceania Space Association, and you have contributed to Space Exploration Project Group at SGAC, that is Space Generation Advisory Council. And I want to tell people that Space Exploration Project Group is particularly focused in the field of planetary geology, and where we are doing really cool projects related to planetary geology. That's how I know, but I'll be more curious about your experience as well. So let's get ready for an amazing conversation with one and only Namishka Mendonca. Thank you so much for accepting the invite, Namishka, sorry. And welcome to AADYA GEO Talks.
Well, thank you, Bharti. Thanks for having me. It's wonderful to see what you're doing. I mean, there is a need for planetary science, and I think the community is growing in India, and I'm just so happy to see that I'm part of the generation where it's actually happening, and to see that you're also contributing, and not just to our generation but future generations as well, and building their skills and capacity building. It's a huge inspiration. So yeah, thank you.
Thank you so much. And I really feel good that people from our generation who are the trailblazers in the field are doing so much work. Like, we are not only studying this field, but we are also putting effort so that younger generation also gets inspired, and they can also get involved in this, and we are laying a path for them as well. Like, for me and for you, I can believe that we created our path somehow in planetary geology, because there were not many experiences or internship projects when I was doing my bachelor's and master's. That is just 2 years ago only. But but these days, many scientists are getting involved in planetary geology as well. So I feel really good about our efforts, about their efforts, and bringing a change in this field. So let's start with the questions. So my first question to you is, because you are from the science communication and STEM field, and I wanted it to be a very fun, loving conversation. So my first question to you is, if you could use any tool or technology, it doesn't have to be like it has to be an existing tool or technology. You could invent one as well, or you could use any existing tool or technology. It is at your disposal. It is just free of cost, just for you. So what the tool and technology would be? You want to use it for investigating the planetary mystery, and how would you use it to explore?
Well, so reaching out to the ends of my imagination, the first thing I would want is a time machine. Seriously, as a geologist, I mean, the amount of effort that geologists put in looking at rocks, and just deciphering an entire history of an entire planet or an entire area is fascinating. And to have a time machine at hand, especially when it comes to solving the mystery of the origin of our solar system, is something that will be very handful, because the more we discover out there, the more planets, and the more we discover about meteorites and asteroids from asteroid sample mission, the more complicated the story becomes. For example, on Mercury, there are these bright deposits that are there inside impact craters. And some scientists have theorized that those bright deposits are actually volatiles or volcanic ash that have been outgassed because of the fractured crust from the impact. And if Mercury is still outgassing those volatiles, it means that Mercury has more volatiles than previously calculated. And it makes the story more complex, because the simple story of heavier elements accreting to form terrestrial planets and volatiles, going and accreting to form gaseous planets, that there is something that happened in between that we are not taking into consideration. So that is something that's really interesting in the sense of protoplanetary formation. The other one, well, I hope one day it comes into reality, is some kind of lander, rover, some material that survives on Venus, because Venus, it's so corrosive. The atmosphere, the pressures are high, the temperatures high, and I think the only probe that was sent was by the Russians, and that too lasted either for a few minutes or a few hours. And I'm just like, that is so bad, because Venus is so interesting, and Venus, it's so, I would say, I feel disappointed that Venus is shrouded in this whole thick cloud cover, because its geology is interesting in the sense that Venus and Earth are twins. Like they have similar densities. They started off the same way, but completely ended up in different end results. One a planet that's full of life, and one that's, I don't know, life threatening. So to see that, it would be really nice to have maybe a rover, lander, or a probe that studies the planet. And in many ways, we could also decipher whether plate tectonics somehow played a role in habitability, because Venus does not have plate tectonics, but Earth does. So that would be very interesting to know.
I must say that you are an educator in true sense, because I asked you a personal question, and the way you explained it so beautifully that anyone from even like 7th or 8th standard could understand, okay, Venus is like that, and we have to explore different celestial bodies like this. So, awesome. You're doing a great job. You're in the perfect field. So you are from both the fields, that is space sciences and geology. What one fact or discovery that never fails to amaze you? Okay, that this is the thing that amazes you, or maybe this could be that point when you felt like, okay, I want to pursue planetary geology. So what's that fact or a mystery or anything?
Well, so yeah, with respect to planetary science, I don't remember a particular moment, but I do remember sitting for some kind of seminar or something, and suddenly it hit me that there are these variety of worlds out there, like crazy. It's crazy because you have worlds that are like volcanically active, like Io and Venus, and on the other end of the spectrum, you have worlds that are icy, like Pluto and Enceladus and Europa. And so it made me realize that this is my reality. It's strange. You find this in children's books, but this is the reality that we live in, and it's so fascinating to see all of these, weird worlds come into play. When they say like reality is stranger than like imagination, yes, it's true when it comes to space, it is true. And that is something that brought me towards planetary science. And in planetary science, obviously, you have all of these different fields of, planetary atmospheres and astronomy as well that plays a role in planetary science. For me, geology and space is like sort of the bridge between imagination and reality. So yes, there is like crazy worlds out there, but at the same time, geology never fails to blow my mind every time, even when it's just on Earth. Like I used to live in I am from Mumbai, so but now I don't live there. I'm studying in Australia, so when I used to go to hill stations like Lonavala, Kandala, Mathiran, you go through these gigantic structures, these tall mountains that are actually a product of basalt, of effusive volcanism that happened 65 million years ago. For those who don't know, it's known as the Deccan basalts, and I think, if I'm not wrong, it's the second or third largest volcanic province on the planet. And it has, and when you're just traveling through that road, to think that you're actually passing through structures made out of lava 65 million years ago. At the same time, the dinosaurs are also there. How cool is that? It's like traveling back in time without actually having to. And that is something that blows my mind. A third thing when it comes to planetary sciences, a realization that, most people have an assumption that the more we explore out into the solar system and study other planets, the more we are neglecting our own. But I feel it's the complete opposite when it comes to planetary science, because the more you study planets, then you start looking at your own planet as just, you start noticing of how unique the planet is, because we haven't found something that harbors life to this complexity. So when we start seeing Earth as like a closed system rather than like an endless, like a factory that produces resources nonstop, but we do it as something that, that's different systems that exist in harmony. And when everyone has this perspective, you try to, it somehow builds an appreciation of our own, even while exploring the universe.
That's so beautifully put, because when I work in the planetary analog system, so every time we have to explore the new worlds like the Martian landscape or the moon landscape, and then we have to come back to our Earth. Okay, what are the analog fields here? And then we have like 2 or 3 different field areas for studying the analog environment. And then we have to combine all 3 of them together and then draw parallels with Mars or moon. So so geology brings us back to the ground. Okay, you are from here, you have to explore field areas, but you have to know your space as well. So that's really beautiful.
Yeah, and it's fascinating to see the range of geological landscapes that's there on Earth. Like we have volcanoes, we have lava tubes, we have dunes, the dunes that are on Mars, you can see them on Earth. You have lava tubes on Moon, we can see them on Earth. And it's so fascinating to see all these different systems that you find on different planets is like just found on our planet. It's so fascinating.
You just took the word out of my mouth that we have analog for every celestial body on Earth. So that's such a beautiful feel that there is a different smaller version of our universe at Earth or on Earth.
That's very well put. Yes, that is true.
It affects me a lot, mostly. So you are involved in STEM education and science communication at the same time. And I believe science communication has a very larger audience, because there are people who don't know anything related to what we are teaching or what we are doing. On the other hand, STEM education has a very particular audience, that the students of Earth and planetary science. So, what surprising or unexpected reaction you have received from someone who's learning space or geology for the first time? You can answer in both the directions. Someone from the science communication and someone from the STEM education as well, because I think both have different audience, so you'll have different experiences in the field.
What you said is actually true. Like the audience ranges are different. I'll talk about my science communication experience first. So I started my Instagram channel in 2020 in the midst of COVID. And before putting videos up, I kept it private. So it was just friends and family who could see my first few videos before I made it public. And so I had an assumption that people did not care about space or what we did or how we went about exploring it. Because when you go for, I mean, let's just say when you go for family events or you go for like social events, people mostly talk about politics, they talk about economy, which are good things to talk about. I mean, it's important to discuss them. But to see no one, being as crazy as I am about like space is like, it's something I was scared. I was scared that they wouldn't be bothered about it, that they'll just like move on with, after watching video. But I was surprised that after I released 1, 2, or 3 videos, they kept the comments were like, this is so good. I never knew about this. Oh my God, this is so cool. And in addition to that, they were also appreciative. Like my friends was like, I wish I had you as my teacher in school. I wish I had you as my teacher at uni. And that sort of made me realize about the barrier that's there between the scientific community and the public. And so like, I realized that, I don't know if it's just India, if it's around the world, that we treat space or science or something as though it's something that only you're smart enough to understand or either you're not. And that's taboo that we really need to clear from people's minds. And that's why science communication is important. So that is one thing that I was really surprised about. And to see, sometimes I come across somebody who's watched my video, like someone who I know, and they're like, I just loved it. I didn't know about this. And I was like, oh my gosh, that just makes my day. Even if one person is looking at the sky and knowing what's happening, looking at the night sky or looking at certain missions and knows what's happening, and that's a win for me. I don't care how many likes or comments, but that's a win when the person on the other side of the screen understands and begins to be as appreciative as the scientific community is of the universe. So that's one thing. For STEM education, I don't know how to put it in this way. So when I was teaching in the space camp, the in-person space camp last year at my own school, I was teaching from grades 2 to 7. And I was, there are 2 things I want to talk about. So first thing was, I was scared that when I teach the kids something or I show them videos, I was scared that they have already seen it, because I mean, they have grown up in the information age. We had the 2000s kids had books and, things to refer to, but they were born in the age of the internet and they have information at their fingertips. So I was scared that, if I'm going to show this video and teach them, they must have already seen it or not. But I was shocked that they did it. I was shocked that, like, okay, but you are part of a space camp. I'm sure you've come to a space camp because there's something about space that attracts you. But to see that they haven't watched any of the videos that I had shown them was kind of eye-opening to say that, we have all this information at our fingertips, and it's really important to show our future generation of how to access the right information when they go into this field. The second thing that it's something that has been noticed before. I did not personally, but I personally noticed it in the space camp was when I was teaching the younger children, so grades 2, 3, 4, they would like shoot questions at me left, right, and center. They were like, oh, is there a black hole? Is there a black hole near us? And why is the star this way? And why is the planet that way? And they would just like huddle around my table and just start shooting questions at me, just come directly at me. But the older kids, the older grades of 5th, 6th, and 7th, they were very hesitant. They were like holding back. And when I was to talk about something or want to share a fact or want to ask something, they would doubt their own logic. And I remember Carl Sagan said about this in a particular video when I was going through Instagram. I seen that Carl Sagan was talking about this, that kids in the American system, in the American education system, they come up with these curious minds of why the sky is blue, why the grass is green, and then suddenly when in their high school, it's just completely gone. And so it made me realize how important it is to sustain that curiosity throughout the teenage years. It's important to create those safe spaces for children where their questions are not judged, but they are welcome openly or even debated about. It's a take thing, and that's something that's very important, and it's like the need of the hour.
Yeah, I totally agree with you with the school concept, because when I organize these workshops, I've realized these smaller kids or younger kids, like up to 5th class, they threw up questions from everywhere. Okay, this is that rock, this is that rock. Why is it that rock? Why you are identifying like this, and why it belongs to this? And I'm really amazed, because they come up with question. You know what? In my village, this rock is like that. What sort of rock would be that? So they come up with really cool and interesting question. And when it comes to like 11th and 12th, they are only focused on their competitive exam, and the curiosity has already dead in them. And I feel very sad. But what I have realized with the general public when it comes to science communication, as you said, so yeah, I realized when it comes when I was so recently I have opened a upcoming geology field program, and it is only focused for geology students. We have also volunteered for it. So it is focused for geology, GIS, and civil engineering people. But now I am getting WhatsApp text and emails every day. Like, is it open for non-geologists? I want to know how you work in the field. I want to explore that geology side of the field trips. So I am getting responses from non-geology or from non-earth science background people that they want to participate in this area, because either from these AADYA Geo Talks or from the Instagram, they got amazed. Okay, this is something interesting, and we want to explore it. Because for these geology people or for earth science people, we have already experienced it in our bachelor's or master's or even during our PhDs, and we want to gain more certifications and more experience in field geology. But for the people who are not from this background, it's something new, and they want to know, okay, what is going on this field? How do you do it? So yeah, science communication is the need of the hour, because even if they don't make a career in this field, at least they are aware about their surroundings. They will start looking up at the landscape in a very different way, and maybe they will start respecting it more. That's what I have experienced, because when you know, okay, this is the origin story of that area, you start respecting it more. Okay, it's not just a rock, or it's not just a landscape. It has a history of like 1,000 years or 2,000 years. So it makes it gives you a perspective when you are traveling to these different things. So I've
never thought about it that way, but yeah, think about that, the respect that it builds up. Yeah, and whenever I tell people about the Deccan basalts and all, and I see their eye opening up, I remember my first geology fieldwork, and I'm just like looking at columnar joints, and I'm like, that was made out of lava? Are you kidding me? that is something so wild and so fascinating, but beautiful, and yeah, something to be preserved as well.
Yeah, that's true. When I went there during my field trip in bachelor's to Deccan Traps, and we were, doing some random readings, and we had our instructor from, I guess, St. Xaviers or maybe from Ferguson. So he said, after doing all the readings and after collecting the samples and everything, he was like, do you know where you were? And you were like, yeah, Deccan Traps. And he said, no, you are standing at the Paleo Lava Channel. You were like, okay, that's something interesting. And that actually gives you a perspective. Even when we go to Himalayas or other parts, okay, this is not just a landscape. This is a history of thousands and thousands of years. And when you are at Deccan Traps, there were a point at some nearby location when dinosaurs were like, just roaming around. So, I particularly love this field because it gives me a broader perspective that I'm just a small dot in this whole universe, and so many things have changed during that time. So let's move on to our next question, which also gives you a new perspective, that if you're leading a space mission, I am sure you want to be an astronaut as well. because
Yes.
every
Obviously.
yeah,
it's I think everyone who enters the space field comes with
yeah.
the I want to be an
I want to be an astronaut. We are all working at different sectors of field, but at the our end goal is same. We want
that's
to be an astronaut. We want to explore new worlds. So consider your dream has come true, and you are leading a space mission to a new planet. What's the first thing you would investigate? I won't be surprised if you say rocks.
that's the obvious answer. Rocks all the way. But first of all, thank you for giving me the honor of leading an investigation to a new planet. Before I tell about like the main steps, I wanted to give like a preface, like a pre-notes kind of thing. So when you go to a new planet, human exploration is the last stage of space exploration. So before exploring any world, you have to gain some passive information about the planet, such as sending orbiters to capture images. Then the next step is by geologists who decipher the features on the ground, called geomorphology. Then you decipher the minerals on the ground, and then you connect the two by creating geological maps, and then somehow writing the story of how the landscape that you're seeing on that particular planet has come into place, and then even perhaps perform a sample return mission. So this is all is happening after that for all those who are listening. So when I was talking about geological maps, and especially when it comes to the scientific community, before when you send out humans to any other planet, if I was going to go out, I would listen to the scientists first, because the scientists, the scientific community, they decide what is something that is known as regions of interest or scientific regions of interest, which are basically landforms or landscapes which are very crucial to answering some questions, some burning questions that they have about the planet. So I would first do that. So I'm sitting having a nice cup of coffee in my habitat, and I'll take out the geological map and I'll see the regions of interest that is decided by the community. And what I would do is first create a traverse path. So a traverse path is something that it's not just a path, it's more of how can you gain maximum scientific output with minimal effort. So that's how you create the traverse path. So I've reached the location, and suppose it's, I hope it comes true one day, but I suppose it is the Jezero Delta. Suppose. Fingers crossed. Suppose it's Jezero Delta. The first thing, as you know, like a geologist, we first try to find an outcrop. So an outcrop is basically a cross section or a nice section that shows all the layers in a particular, let's say in a particular landform or a particular feature. So if there's like a butte or a mesa or like some cross section that's there, I would go there first, and then I would take a sample out of each of the layers, because each layer might give clues about something related to the water flow or the water content. And if I had like a handheld spectrometer, like a mini X-ray fluorescence, machine, I would go there and kind of, analyze and see what kind of minerals are there. So I could maybe get some immediate answers, as a astronaut, going out into the field. And many times I'm expecting this to happen, but I think it has happened during Apollo, where you kind of do all of this things that you're supposed to do, but then you find a feature or you find a rock so interesting that was completely unexpected, and you're like, you know what, I think you need to investigate that. And so I'm expecting something like that is going to happen, especially, and it's happened many times, especially I don't know how recent, but I think it's quite recent, where the Perseverance rover was traversing and going to a particular site, but on the way it spotted a zebra looking rock, like a rock with black and white stripes, and the whole community just went crazy. They were like, oh my goodness, this looks like a metamorphic rock, but Mars does not have tectonic plates, not a metamorphic rock get there. And many unanswered questions. So I'm guessing that would happen, and then so it'll be like a rinse and repeat. I think what most people don't realize is that doing an extravehicular activity on a planet is just field geology on another world. So what you do there may be certain differences here and there, but the baseline, everything is just the same. And when you go out into the field, it's mostly the most important thing is having a keen eye for observation and an open and curious mind. So that's important, yeah. But that's how I would go about investigating. Yeah.
You know what? Recently, I was talking to a senior scientist who's a system engineer as well. So we were together on a mission, an analog mission at in Utah at MDRS. So we both were talking like, every space mission should be led by a geologist because we know the field area, we know how to, go about the field locations and everything. So you have rightly put it there that the way you will go about with the mission and with the field geology, this is the requirement for every EVA, that is extravehicular activity. And we do similar things when it comes to analog environments, or when it comes to these MDRS or FMARs or the high seas station. So we have chosen the right person as the space leader, the leader in the mission. Yeah. My next question is, with your diverse interest in space science and geology as well, so if you could combine any other two fields with geology, or like it could be physics and geology, or chemistry and geology, or biology and geology, so any two fields with geology or with planetary science. Geology and planetary are already together. So if you have to include one more field from any science field or engineering side, what that field would be and how would it work?
So with respect to planetary science, I think that in the future, like, yes, there are currently missions we are sending, like Perseverance, and in the next few days we are going to launch Europa Clipper mission, because I think icy worlds and the outer edge of the solar system is going to be the new hot topic for the next years. I think people are done with Mars. I am disappointed, but I feel like some of them are like done with Mars. So Perseverance is the only big thing happening right now. And the trend that I see, yes, there is some sort of trend that's coming up with astrobiology, where we are trying to decipher the habitability of a world or a planet and whether it hosted life. But at the same time, if you want to know if a planet or a world hosted life, you need to know the chemistry first. Yeah. And the chemistry is very important because that's what plays the role into the origin of life. So I do remember someone asked me the similar question, and I was like, without geochemistry, you cannot have geobiology. Like it does not work that way. And I feel that no field in planetary science is devoid of the other. Everything is connected to each other. Geophysics will come into play because maybe some impact happened, and maybe there's some hydrothermal. So let me put it this way. Okay. Origin of life. Let's say maybe it comes from like a crater, like Gale crater. How did they know that? Well, geophysics, maybe there was an impact. Then geochemistry, suddenly there were like hot fluids that were going inside the crater, inside the cracks, inside the fractures, and later the crater, if I'm not wrong, hosted this entire body of water, and then all of these minerals came into play, and then you have astrobiology. So I don't think that there's a field that's devoid. Certainly, there are a lot of missions that are now specifically moving towards, I would say, understanding asteroids, understanding the outer region of the solar system, and also understanding the moons of especially Jupiter and Saturn. Because they are worlds of their own, and they could have some sort of role in the origin of life. So I feel that is what is going to happen. So if I would pair, I think everything is paired with one and the other. There's nothing left. So yeah, I myself am doing, like, I did geology, but now that I'm doing planetary science, I feel a lot of geophysics, which I've never thought of before. But a lot of geophysics is also coming to play, and perhaps a bit of geochemistry. So it's all a mix, one way or the other. Okay. What I'm committed to working towards is bringing planetary science in education. So for now, we do have planetary science at research level, but I feel that it's necessary for it to trickle down into the education system, into textbooks. For example, in trigonometry, like it's purely mathematical. The problems from the textbooks are so boring. Like they're like, calculate the height of the building, calculate the height of the pole, and you're like, well, I'm not going to go out there into the world and calculate the height of a building or geometry. But when when students realize that astronomers actually used trigonometry, especially in the past, to calculate the size of planets, to calculate the distance of planets, and eventually it led to, from geocentric, from thinking that the Earth was the center of the universe, to knowing that the sun is actually the center of the solar system. That would actually pique their interest.
Yeah.
And especially planetary science, not just the facts and the research, but also the way that we logically develop a story in deciphering the mysteries of a world. So, like, suppose you explore a new terrain, and it requires someone who asks a lot of questions, has a keen eye for observation, and the children already have that. We just have to let them apply and strengthen it, because also space is a place where things that were first thought of as impossible is actually encountered in reality. And so we want children to develop their imagination and logic. So I feel that is something that's really needed if we want to help sustain their curiosity all through their years.
Yeah, that's true. Because when I come across students, you have too during the space camp, that people actually don't know about the astronomy or astrophysics, or most of the people relate astronomy with astrology. So we have to bust these myths, and we have to cultivate this planetary science in particular into the textbooks. I remember we just had only 2 or 3 chapters in physics textbook, and those 3 chapters only motivated me to pursue space science ahead. But I believe that more chapters related to space science, not just origin of universe, but more into geology as well, and more into astronomy and the future space missions, be it in the fictional format or be it in the textbook non-fictional format, they are required to keep the momentum going in the space science field. Because like for every generation there is a new invention or technology, and for our generation I believe space science would be the one. And if we can't keep the momentum on for our next generation to follow it, so that's our that's our bad luck then. We have to put efforts to bring it to this field. Recently I had a talk with my professor, and he mentioned that NCRT is also doing some changes, and they are including 2 or 3 chapters related to geology, and we are teaching or we are training teachers of 6th to 10th standard that how you can teach geology. And the bad side is that the teachers don't even know what geology is. So
this reminds me of I first encountered geology. Actually, I don't know how, but in the 6th grade. No, sorry, not even the 6th or the 8th grade, where they had these few chapters of in the geography textbook about like different types of rocks and the volcanoes and faults and folds, and I got pretty fascinated. And it came at a time when movies like I was watching Journey to the Center of the Earth or The Core, and it just built up my fascination, and I was like, I need to do geology.
That's really right, but because even I remember that rock cycle chapter, and for a very long time I related that to geography. I didn't know that there is another field called geology, and that is totally another story how I end up in geology. But I remember talking to my professor, who's an atmospheric scientist, and I asked him, what, sir, I always wanted to be an astronaut. I wanted to be in the space science field. I don't know why that is the first semester of my geology career. And he told me, what, engineers are already, building these robots and spaceships and everything. But who is actually working in this field? And I innocently asked him, who? And he was like, you, scientists like you. And you don't even know that geology is such an important part when it comes to space science. Who is going to decipher all these rock cycles, or who's going to tell us what is that rock or what is that landscape? Engineers will just build the robot, but they don't know what is the science behind it. So you are involved in that category. You are involved with the basic science or why we are going there. So that time I like, okay, now space is still in my career, in my life, and I can still pursue that field. So I owe him that he made that spark again. Okay, you can be a space scientist once again, because I felt like, okay, I can't do space anymore. So this brings to my next question. You are studying at Curtin University. So what specific aspect of planetary science you are currently working on in your degree program? And or is there any particular thing which not even in your degree program, but you are like personally dealing in your research project, or any broader question about universe you have?
Well, the specific aspect of planetary science is the one that I'm working on right now. So the program is actually more research focused. So I barely had maybe 2 or 3 courses, and that too it was centered more around practicals and professional practice. But the main crux of my degree is the research project that I have, and I didn't know what to expect before entering it. I knew that it was about ice underneath the surface of Mars, and I was like, okay, I'm going to go into it. And then when I started reading these papers, it suddenly just opened my mind. So let me just explain. So my topic that I'm working on is fresh ice exposing craters on Mars. So these are like tiny craters, let's say order of like, so the tiniest ones that I found so far in my work are like 1 meters to like, I don't know, there's just 25 meter, 1 meter, there's that range. And they have excavated ice underneath the surface of Mars. Now, the reason we call them fresh craters is because they're not old. They are not like millions or thousands of years ago. They are like freshly made as the orbiters are roaming around the planet. So scientists have actually like detected a change in the landscape, and they're like, oh, there's a crater that's formed. And then they use another instrument, the HiRISE instrument, and then when they capture the color image, and they were like, there's like bright white stuff that's excavated out of this crater. And then they realized that it's actually ice. Now, for those who don't know, on Mars there are 2 kinds of ices. There's dry ice, so ice made of carbon dioxide, and then there's H2O ice, which is water ice. And the ice that they found is water ice. And that was something that was completely mind-blowing. And till now, we have, I mean, the fresh craters that we have that have been detected around, I think, 1,203 of them from my knowledge so far, but 48 of them have excavated ice. And the fact that they are tiny, in the range of meters, means, and the fact that they are formed, freshly in the past 10 to 15 years tells us 2 things. One is, yes, there is an ice table that's present underneath the surface of Mars. It was previously detected by orbiters around the planet, but until we sent the Phoenix lander and until we seen these fresh craters, we did not know that there's actually like ice that's there underneath. And the second thing is the ice table, because the craters are so small, they have excavated just a few, let's say less than a meter underneath the ground. So to find ice means at that depth means that the ice table is just very close to the ground. It's very you can say very shallow subsurface ice. So my work is combining remote sensing observation and numerical modeling to kind of think of how this ice is structured underneath the surface of Mars. So I am currently doing this research under the supervision of Dr. Katrina Milkovich and Dr. AADYA Jones. And so we are trying to decipher and see how deep or how thick this ice table is. And by understanding these ice table properties, we kind of answer the big 3 questions, or kind of big 3 challenges. The first one is the present and the past climate of Mars. So like the ice table is very sensitive to like water vapor, atmospheric pressure, temperature, humidity. So once you come to know like, okay, how is the ice table, how deep it is and how thick it is, we can kind of decipher the climate on Mars currently. and also the past climate of Mars, because some scientists have theorized that the ice that we are finding now is actually the ice sublimated already from a glacier deposit that
Yeah.
covered the planet when it was in high obliquity or high tilt. And
Yeah.
so Mars used to almost have a tilt of like 45 degrees, and so this could lead to like ice forming or glaciers forming near the equator. And the fact that we find these craters near the equator and in the mid latitudes may give us some information about the past glacial episodes on Mars. The second question is that the ice that we find today might probably be the surface water on Mars that is migrated underground and frozen. And if this water somehow has microorganisms inside of it, most likely ice must have preserved the past life of Mars. So it's a good astrobiological discovery and potential site, to study about the astrobiology of Mars. And the third is, so these two are like both looking into the past. The third is looking to the future. When we are sending astronauts to Mars, they can use ice to sustain themselves on the planet. I mean, like I said, they are just a few centimeters below the ground. You can like just scoop them out and you can get ice. So the thing is, once we come to know how deep the ice is, how thick the ice is, if it's pure, if it's mixed with regolith, it will give information to future explorers to be like, okay, okay, here is where we find a lot of ice, here is where we don't find a lot of ice, and they can use them for oxygen, water, food, all of those things. So I feel that that's how it kind of helps answer all these big questions in the universe about the past life on Mars, about the past glaciers on Mars, and looking forward to the future. I'm sure once they study this ice, maybe a lot more secrets will be uncovered.
Wow, that's such a beautiful study. And this is big news for me that, we have like recent craters on Mars, because I am doing a current project in Ladakh, which is related to permafrost. So for that yeah, we are doing that analog study of Mars, that Mars have permafrost mounds. So Ladakh has permafrost mounds as well. But I didn't know that there are craters forming over there and the ice is coming on the table. And I must tell you that we are still in the papers right now. But the ice, the permafrost ice layer in Ladakh is not that close to the ground level. It is very, deep. Though Ladakh always have these glacier deposits time to time. Whenever it's the winter time, we have it is snow covered. But still, the ice layer we have found in the Ladakh region is very below from the ground level. But with the Mars, it looks like very recent deposit, because after even 1 meter of crater, then we are seeing the ice, and that's to H2O ice. So it means that the activities are very recent. I am really looking forward to your project and the papers you will publish from this research project. It will blow mind of many paleoclimatologists who are working in the analog environment. Like, this is totally different. That's totally a new project.
And the best part, sorry, thank you so much. No, the best part is when you spoke about permafrost, I remember the thing is, the craters that we find, most of them are in like permafrost like regions where ice is either sublimated, or we call like brain terrain on Mars, these ice sublimates. So I am going to kind of look into the permafrost side of it as well, to see how the Mars icy permafrost probably looks like. So yes, it will give a lot of information.
I'm super happy for your project. It will, it's really of interest for many paleoclimatologists and who are all working in the analog environment. Especially this study is the trending study in Ladakh, because I want to build new sites in Ladakh, and permafrost is of utmost importance. And yes, as you said, that when astronauts will go there, they can actually use that for their sustainability. So it's a great study, and I wish you all the best for this project. I'm so happy that you got this project.
Thank you. Sorry, another side story I want to give about this ice is that I want people to know to go and research about the Phoenix lander and the And there is a particular feature which is known as holy cow. Because when the Phoenix lander landed on this polygonal region, polygonal terrain where ice was expected, they did not expect ice to be so close to the surface, because once the lander came and the thrusters blew the dust away and the lander was there settled on the ground, below the lander was a full lens of ice. And when they took the photo, they were like, oh my gosh, this is something that's exciting. That's how the actually the trench, the terrain is known as holy cow, because that was their reaction.
Okay, now I got it. So this brings to my another question, not really a question, but sort of a discussion that when there is more of deposition, then the ice table or the layer of fresh ice will go deep down. But when there is more erosion, then the ice will come towards the surface because the upper surface has been already eroded. So what do you think, like, because of more erosive activity on Mars is bringing this change that ice table is near to the surface, or is there any other phenomena, like any sort of discussion sort of this question is?
Well, we do know that there is some kind of vapor deposition that that happens of ice. So we have like the first few centimeters, we know maybe like fully pore ice, so ice that's in the pores. But the ice that's so close to the table, actually even everybody is actually invested in figuring out why. I think it's mostly about the equilibrium between the atmospheric vapor deposition and the, what do you say, like the regolith is kind of being some kind of like a protective cover so that ice does not sublimate, because the pressure on Mars is very low. So once ice is exposed, it will sublimate. That's how we knew that it was water ice. So for water ice to survive at those depths, there must be some sort of cover, some sort of temperature ranges, some sort of pressure that's sort of keeping it from sublimating. So yeah, there is some kind of history to it, but I really need to look into it more.
Okay, great. So this is my last question to you. This is like I ask this question to every scientist now and then because I want to know, like, what is keeping you up at night? What sort of planetary science question or planetary geology related question that keeps you up at night and you feel like, okay, I have to solve this mystery in this lifetime, or I have to tackle this in my future career? Or is there any question or mystery related to planetary science or planetary geology?
Well, there are two questions that are keeping me up at night. One is the one that I'm currently working on, because I'm like thinking, okay, what is the structure of the ice? How did the ice get there? But the second thing that keeps me up at night is wondering when the Perseverance samples are going to come back to Earth. Because once that Pandora box is opened, it is going to, I feel like there's just going to be a research paper every month, because something or the other, some new discovery or the other is going to come to light. The challenge that I would like to contribute to, and sometimes I think about it, is how astronauts are going to survive on the red planet. Because going to a planet, easy, landing on it, a little difficult, but we've done it, and we've already achieved, landing on the moon. But living on a planet, living on a world with limited resources, or being independent of resources from Earth is a big challenge, but it's not impossible. That's why we have something called in situ resource utilization, which is ISRU, which means that how do we find these solutions? How do we solve the challenges of using the resources of the planet that we are on, like using the resources of Mars to survive on Mars rather than depending on resources on Earth. So since the work that I'm doing now revolves around the ice table situation on the red planet, and since ice is going to be used by astronauts, I want to help, in sort of defining landing sites or traverse paths where astronauts, when they have their boots on the ground, they can use that ice or use whatever engineering marvels that are going to come from extracting the ice and using it to sustain themselves. So that is a question that is a challenge that I would really like to contribute to. And along with my research, I'm just looking forward to participating, sitting in rooms where they are discussing about, okay, we are sending humans to Mars. What are your thoughts? That those are the rooms that I want to sit in. And at the same time, as research is happening, the challenge, another challenge I want to advocate for is space for all or earth for all, because ensuring that, yes, there are mysteries that keep me up at night, but ensuring that space and its mysteries are there for any passionate person who's looking to solve it, irrespective of their background or their age. And to, to see the roadmap for space exploration, I'm just excited to see how it plays out in the next few decades. But at the same time, I don't want to stop advocating for space for all, because exploring space is an effort of humanity, and if you don't involve the whole of the human race with you, it's not going to be something that's fruitful. You need to involve everyone.
Yeah, that's true. And I think the philosophy of space is for all. We are representing human species in space, and it shouldn't belong to just scientists or engineers. It has to, from every background. Like, even if you are an artist, you are a musician, you are a dancer, you're a photographer, you have to be part of the space. And the space for everyone, or space for all philosophy, I swear by it, and I keep motivating people that even if you are from a different background, you haven't studied the geology or the physics, you can still be a part of space. And I'm happy that many people think alike. And I totally agree that we have to sit in that room who's deciding the, human space exploration and origin of life projects in near future.
That's true, yeah.
Thank you so much, Namishka, for such a beautiful interview. And I'm so happy that you and I share really good passion for geology. And you have motivated many students. For the questions, I must say that you not only, educated the strong audience of geology and planetary science, but the questions, the answers were really for a broader audience as well. Those who don't know anything related to space science, you were able to explain everything. So you're doing a great job when it comes to science communicator and a STEM educator. And I'm super happy to know about your research project. Because similar thing I'm doing in Ladakh, but you are actually doing it on Mars. So it feels super happy that, my sister is doing that project, and, the human exploration is doing that. And it feels super happy to know that people are doing great things when it comes to future of space science and space exploration. So thank you so much for coming to the show, and thank you so much for answering all the questions. And I feel really happy to connect with you over this.
Well, thank you so much. Thank you for inviting me. First of all, I just want to say that the initiative that you've started, and especially this GeoTalks, is something that I've not seen before. And to see it, come into fruition, and come and see your talks with all of these scientists and bringing them to the audience, bringing them to the public. And like I said, there was a barrier, but you're like actively breaking that barrier between the scientific community and the public, and to see you smashing that out is something that is really commendable, and I'm really excited. I'm so excited to know that there are all students that are going to hear about this, and if they have any questions, please feel free to reach out to me, via Instagram or email. I think in the comments or in the comments, there will be some information. Yes.
Yeah.
So, yeah, and I'm so excited, on the other hand, to see that the work I'm doing in space, someone's doing that on Earth. Like I said, like we are just putting in the numbers, we are getting the data, we are not really on the ground, but like that's imagination, and like that's a lot of theory, but you're actually having boots on the ground, and bridging that gap of space and geology together. So that is something that I really like, that this is like linking up really well.
Oh, thank you so much. And I am pretty sure with this interview, many people will come to me with the questions that, they want to connect with you. So I'll put down your Instagram ID in the description as well as your LinkedIn ID as well. I know you are super active on Instagram and then on LinkedIn. So yeah, I'll be happy to connect many students with you so that they can learn throughout their school or college journey. And to all the people who are not from this background, but they still are curious about science exploration or space exploration, your channel is the go-to channel for busting all the myths and decoding all the cool stuff. So thank you so much, Namishka. And I would like to wrap up this episode of AADYA Geo Talks. Thank you, everyone, for being with us. Thank you.